All right, so start a new section in your notes titled Unit 2, Polynomial Relationships, and we're going to go over what polynomials are all about. So Unit 2 is all about polynomials. So whenever I say the word polynomial, some kind of understanding should pop in your head. And if you don't know what a polynomial is, it's fine. That's what we're going to go over here. But this is an example of a polynomial. Polynomials have terms. So if you notice, each one of these things are terms. They're separated by subtraction or addition. And a polynomial can only have positive coefficients. Positive exponents. So if you notice right up here, it's x to the fourth. That one's positive. This one is x to the first. It can also have a constant. So this one has no x's. You can have a constant. But you can't have x to the negative fourth or x to the negative 2 or x to the negative 1 or anything like that. You can only have whole number positive exponents, or you can have 0, I guess, because 5 is really 5x to the 0 power, but you don't really need to know that. Okay, so I have another slide right here that shows you don't need to write this down so much as long as you understand what's going on. But a polynomial, if you notice, all these exponents are 0, 1, 2, 3, etc. Okay, you can't have negatives, like I just said, and you can't have an x on the bottom, because if you have x on the bottom, then it's x to the negative 1. Okay, so it says polynomials, not polynomials. Again, you don't need to write that down. You just kind of have to know it. I'm going to try to remind you every single day, so you don't really need to worry about writing this down. You also should technically know this already because you covered it in intermediate algebra, but that was a while ago. So if you forget, I'm going to remind you each day. Okay. Here is an example of a graph of a polynomial. And one thing you have to know about a graph of a polynomial is that they're smooth and they're continuous. Okay? There are no sharp turns. It just kind of, everything's a nice kind of glided turn, and it's continuous. There's no holes, jumps, or gaps. So if you were drawing that graph, you wouldn't have to lift your pen off your paper to draw it. Okay? So they're continuous and they're smooth. It's not like an absolute value where it's like a perfect V or anything like that. Okay, next, there's a thing called a degree of a polynomial. And the degree is just, and it says it right here, the degree is the largest exponent of x. So in this case, the degree is 3 because that's the highest exponent. The last unit, we only dealt with exponents that were 2. Okay, that's quadratic. We only dealt with 2. In this unit, we're going to deal with exponents that are 1, exponents that are 2, exponents that are 3, 4, 5, maybe even 6. Okay? So the last unit was just 2. You could focus on that. Now we're going to focus on other degrees. Again, a degree is the largest exponent that's there. In this case, 3. Okay, standard form of polynomials. You're going to always see it like this. I'm never going to try to trick you in this way unless I tell you to put it in standard form, but I'm probably not going to because it's a waste of a question. But a standard form just means that the powers go in descending order, okay? The biggest one is 6 is first, and then the next lowest one is 3, the next lowest one is 2. If you notice, this is called standard form. This top one is not. It's got a 3x squared minus 7, and then 4x cubed, so it's the same one as this one down here. But if you notice, it's not in order. The powers are not in order. Okay, the highest degree is 6, so that should go first, then 3, then 2, then the constant is last. That's standard form. I'm always going to give you the equations in standard form, or the expressions. Every polynomial will be in standard form. Okay, if it's an even degree polynomial, you probably already know this, but there is symmetry to it. There is an axis of symmetry. It doesn't matter if it's x squared, or x to the 4th, or x to the 6th, x to the 8th, whatever you want. It's always going to be like this. To kind of show you that, I'm going to pull up Desmos here. And I'm going to say f of x is equal to x squared. Okay, it's symmetrical. G of x is equal to x to the 4th. Still symmetrical, but if you notice, it's less than the blue is less than the red up until 1 and -1 here. And then all of a sudden the blue is higher each time. Okay. X to the 6th is going to be the same thing, only it's going to be even less than the blue, but then ultimately ends up being greater outside of it. Okay, and it's going to always be like this. Okay, there's going to be that symmetry. Now you might be thinking, why do I need to know this? Well, eventually you're going to get certain problems where it goes, which of the following, could be the correct equation for this polynomial, and you have to know whether it's, x squared or x to the third. And they look very different. So anything that's even like these, we'll do x to the 8th. Going to be that way. Now, if I change this x squared to, like, let's just say x to the 100th, here's 10. But watch what happens as I add more and more zeros. Okay, it starts just getting more blocky in a way. If I add a bunch, it looks like it's a straight turn, like a left turn here, or right turn. But if you zoom in, it actually does round off. You just have to zoom in a lot. This might run out of memory. Okay, there you go. You can kind of see the curve there. Okay, you had to zoom in a lot, but this is also x to the 1,000,000th power. You'll never see that. Okay, I probably won't even go to 10. I really probably won't go past 6, but I don't know yet. We'll have to see. So symmetry is the main thing for this. Again, I would write this in your notes because there's going to be a problem where it says, like, which of the following could be the correct polynomial equation, like I said before. And if you see it's symmetry, if you forget that, you can look in your notes and go, oh, symmetry, it's going to be even. So it can't be x to the 3rd. It could be x squared or x to the 4th. Now, if it is odd, you'll notice they look something like this. Okay? There's not really symmetry on this. It's almost like if you put a mirror, like right here, and then kind of flipped it, I guess. If I flip this part right here and put it to the other side, then it would look more like this. But it kind of forms that, like, weird S shape, N shape kind of a thing. I don't know. Okay, and they always look like this. Let's go back to Desmos here. There it is. I'm going to change this to x to the 1st. X to the 1st. I'm going to change this one to x cubed. Okay, I'm going to change this one to x to the 5th. X to the 7th. Turn these on so you can actually see them. And you can see they all, there's no symmetry to them. They start low and end up high for each of these. Okay. Now, if you wanted to, you can flip them by putting a negative sign in the front of it. So now they start high and go low. It's still, you'd have to see that it is odd numbered because it doesn't have that symmetry. Okay. Now, if you want to do the symmetry, those also flip upside down when you put the negative in. You see they're all pointed downward now as well. Okay. So negative makes things point down, essentially, when you're going left to right. So left to right, it's going down here. If I got rid of it, made it positive, now left to right, it goes up. You notice this is going up to the right. I know this is a lot of facts. That's part of the reason why I want you to use your notes on the test, because then you don't have to remember everything. Okay, there's this thing called relative extrema. You can have a relative min or a relative max. Extrema just means extreme values. Okay, so it's either a min or a max. That's what extreme values means. And it says right here, a polynomial of degree 4. So remember, that means the power is 4. If you notice, there is some symmetry on this. They're both going up on either end. But if it's degree 4, it can have 3 turning points. Turning points are just where it's a hill or a valley. Okay, like this would be a turning point right here where it's turning. That's a valley. And then over here, it's a hill. And then over here, it's another valley. If you notice, there's 3 turning points because you can have this one here, 1, 2, and 3. So because you can have 3, that means that it's probably x to the 4th. Okay, anything with x to the 4th, it's going to have 3. It's always just whatever the degree is minus 1. Okay, but you could have less than it. For example, this one's x to the 4th here, and there's only 1 turning point. Okay, that is possible. That's why it says you can have 3 turning points or less. You cannot have 4. You cannot have 5. If it's a degree 4, it limits it at 4 minus 1, which is 3. Okay. We are used to quadratic. So let's go back to quadratic here. If you notice, there's only 1 turning point. It goes right here, and then it turns going up. Okay, so if there's 1 turning point, you add 1 to it, and you get 2. That's the degree. So if you take whatever the degree is and minus 1, that's how many turning points you potentially could have. Okay. If it was x to the 3rd, you'll notice there's only 1 turning point. But you can add more character to this, or if I did this, see now there's 2 turning points. You can even make it do this a little bit. Now there's even, you can really see the turning points, but there's only 2. Okay? You could make it where there's 1, but you could have at the most 2. You cannot have 3. It's impossible. If you figured that out, then you broke math, and you should be famous. Okay? So again, you just do the 3 minus 1, and that's equal to 2. That's how many max turning points you can have. You can have 2 or less. Here's the less. You can't have less than 1, though. It's impossible to make this not have 1. Even if I just change it a little bit, it's still going to have at least 1 turning point right here. Okay. If it has no turning points, then it's linear. Okay, the power for linear is to the first power. So if you did 1 minus 1, that's equal to 0. There's no turning point, so it actually still works. Okay, so relative extrema, also known as turning points, your degree will tell you how many there are. You just take the degree and minus 1. It could be less than it, though. Fundamental theorem of algebra, we talked about this a little bit in the first unit, and it basically says whatever the degree is, that's how many roots there are. Okay, sometimes you need complex numbers for that, but if it's degree 4, there's 4 answers. If it's 5, then there's 5 answers. A root, or a 0, is where the polynomial is equal to 0. You should already know that. If you notice right here, there's 1 turn, and then there's 2 turns. That means this is x to the 3rd. It kind of looks like it's x to the 3rd. But if you notice, there are 3 roots, which makes sense. X to the 3rd, that means there should be 3 answers. There are 3 answers there, 3 solutions. Complex roots always come in pairs. Okay, there's always 2 of them. So if you have 1, there has to be another one. There's no way of getting it to be just 1. We're not going to go over the theory of why that is, because it's beyond the scope of the class. But just know they always come in pairs. And here's a little table. Don't write this down right now. We'll go over this later. But if you have a degree of 1, that's linear. That's x to the 1st. It's linear. There's only 1 root. Okay? If you can imagine a graph, let's just say 3x minus 1. There is only 1 solution right there. Okay, it's impossible to have more than 1 with it still being linear. Okay, the next one, if it's squared, there's 2 roots. And the 2 roots can either be real roots or they can be complex roots. We went over this in the last unit. You define imaginary numbers, imaginary solutions. That's what that is. It can either be 2 complex roots or 2 real roots. It can't be one of each. It's either one or the other. Because complex pairs always come in pairs. Complex roots always come in pairs, sorry. Okay, you can't have one without the other. So because of that, it's either both of them are complex or none of them are. Okay. For a degree of 3, that's x to the 3rd. You can have 3 real roots. So let me show you 3 real roots really quick. So if I had something like x to the 3rd minus 3x squared plus 1. Okay, here's 3 real roots for this. 1, 2, 3. But if I wanted to, I can make this where, let's just do minus 1. Now there's only 1 real root right there. So you might be thinking, what are the other 2 real roots, or what are the other 2 roots then? Well, there has to be 3, and there's only 1 that's real. So those other 2 are complex. It says right here, 1 real and 2 complex roots. They always come in pairs. You have to have 2 of them. You can't have 1 or 3 or 5. It has to be an even number. 4th root, you can have 4 real roots, or you can have 2 real roots and 2 complex roots, or you can have 4 complex roots. You can't have anything else. I'm going to show you that one really quick. This is going to be tough because some of this is just making them up. Oh, never mind. That was pretty easy. Here's 2 real roots, which means the other 2 are complex. They're imaginary. You'd have to figure them out some other way. We're not going to worry about that until later, though. But if I wanted to, I could move this up a little bit. Let's do this. Plus 0.5. Oops. 0.5. That's embarrassing. And now you'll see there's 1, 2, 3, 4 roots. Okay. Before, this was a minus 1, and there was just 2 roots. Here, if I move that up a little bit, now you can have 4. Okay. Another thing you can do is you can have it where there's none. So let's just add 5 to it. Oops, let's add 15, 10. Now if you notice, it doesn't intersect it at all because it's all the way up there. Move it down a little bit. Okay, so now there's 4 imaginary roots on this because it doesn't intersect the x-axis anywhere. Okay. So we're going to go over this, in more detail. Again, this is just kind of an intro to what's going on here. So then this is like the actual start of the unit. This other stuff was just kind of based on the last unit. But here's where the unit really starts here. There's 3 sections on this. So polynomial graphs, polynomial expressions, and then systems of equations. We've already done systems of equations before with linear systems, but we're going to do ones with nonlinear systems as well by graphing and just by hand, each of those 2. But we have done these before. Okay. I might throw this one out, though, toward the end if we don't have time. But we're going to start with polynomial graph characteristics first. Again, that's the turning points, that's the degree, that's the negative or positive sign in the leading coefficient. But here is the breakdown of what's going on in this unit. There's 4 things that we're going to analyze with these graphs. The leading coefficient, so whether it's pointing up or pointing down, it's either positive or it's negative. The lowest possible degree, if you remember, the number of extrema plus 1 tells you the degree. So if it's x squared, there should be 1 extrema because you minus 1 from it. Okay? There's 1 turning point, you add 1 to it to know that it's squared. So you take the number of relative extrema and add 1 to it. The lowest number of complex solutions, okay, so if it's x squared, there should be 2 solutions. If it's x to the 3rd, there's 3 solutions. That's what that means. We just went over that a second ago. Okay, x-intercepts and y-intercepts, you should know how to do those already. Okay? And you're just looking at a graph and seeing where the x-intercepts are. You're looking at a graph and figuring out where the y-intercepts are. Okay, so let's go over each of these one by one. So right here, the leading coefficient. The sign tells you where it's pointing. If it's positive, like this one right here, it's pointing up from left to right. If it's negative, it's pointing down. Okay? I always just think, how do you want your salary to look? You want your salary to be going up throughout time. So that's positive to have a positive salary. So I was just thinking of it that way, and it's going to be going up. You don't want it to be going down. And this is very positive as x increases, y increases. Negative as x decreases, y increases. Okay. But really, just think about the graph. It's going up or it's going down. And you're always going left to right, like you're reading a book. You go left to right each time. Okay, if it's x squared, something like this, if you notice, it's still going up to the right and then going down to the right, depending on if it's positive or negative. So if you change it positive or negative, it flips it upside down. You have to know that because it's going to be like you're picking out a lineup and you're saying, which of the following could be the equation? And you have to be able to know where it's pointing. That tells you whether it's positive or negative. Okay, we're going to do some examples, so I'll show you what I mean. Okay, this one, it's x to the 3rd. If you notice, the same rule applies. Left to right, it goes up here. Left to right, it's going down here. So the bottom one is negative because it's going down. The top one is positive because it's going up. Now, I know the top one isn't going up all the time. It's going down like in this middle part right here, but I don't care about that. I just care about the long run. In the long run, it's always going to go up. There's just a little blip in there. Okay, lowest possible degree. You just take how many relative extrema there are, and then you add 1 to it. Okay, we already went over this. This first one is linear. There's no turning points. There's no hills or valleys. There's no humps or valleys. I can't think of any other way of explaining that for this one. So because of that, there's no relative extrema, then it's linear. So it's going to be x to the 1st. Okay, so this degree right here for linear is 1. The degree for a polynomial, it's linear, is 1. If it's 2, it's quadratic. If you notice, there is 1 hump right here, 1 relative extrema, 1 turning point. So you add 1 to it, and then you get 2. That is an x squared equation right here. Because there's 1 hill or valley, and you add 1 to it, so that's 2. This one up here is x to the 3rd because there's 2 hills. I'm sorry, there's 2 hills or valleys. There's 1 hill, 1 valley. 2 plus 1 is 3, so that's x to the 3rd. Excuse me. And that's the lowest possible degree. The reason why I wrote lowest possible degree is the following. Hold on, let's go back to this thing right here. You could have it where it's like x squared, like this. There's 1 hill, so you go up, it's x squared. But x to the 4th, there's still only 1 valley, I should say. There's 1 valley on this one, even though it's x to the 4th. So that's why it says lowest possible. It could be higher, but we can't possibly know that. If I just showed you a graph that looked like this, how would you know that's x to the 4th? You could think maybe it's x to the 6th. You know, if you were trying to pick these out in a lineup, how would you be able to tell one from the other, really? Okay, they're too similar. So you know the lowest possible would be 2 on this one. It could be 4, it could be 6, it could be a million. If you remember from before, it still follows the same shape. But you don't know. That's why it says lowest possible degree. Okay, x-intercepts. From looking at the graph, all you have to know is that, like for this first one, it's got a -2 and a 1. Those are the x-intercepts. For this one on the bottom, there's no x-intercepts. If you notice, there's no x-intercepts, but that just means that you have complex solutions. You have those imaginary solutions in there with I. Okay, the top one, you don't have I because there's 2 solutions. The bottom one, there's none, so that means they're imaginary. I don't care about the math so far right now. I just want you to be able to look at the graph and be able to tell the x-intercepts. The y-intercepts, same thing, only you're always going to have a y-intercept. It's impossible to not have one, and you will only have one. You cannot have 2. You can only have one y-intercept. You just set x equal to 0, or you look at the graph right here, -2. Look at the graph right here, 1. Okay. So that's basically all of 2, 1, 1. The x and y-intercepts, that should be nothing new. You've seen that before. Now, the leading coefficient, whether it's pointing up or pointing down, that's new. Positive, negative. Positive, negative. That's what you have to remember for that one. And then the lowest possible degree is how many terms there are plus 1. Lowest possible degree. How many terms there are plus 1. Okay. X-intercepts and y-intercepts, that's old stuff. So you should know that already. Are there any questions on any of this? I'm going to start doing some example problems now to see how we're doing. Okay. This. All right, cool. So I'm going to give you a graph, and I want you to tell me. Well, I'll write the questions down. What you need to tell me. All right, so here's a graph. I'm just going to sketch any old graph here. Let's do, I went down, then up, and down right here. Okay. Things I want questions answered for this problem. Number 1, I want to know the leading coefficient. Is it positive or is it negative? Okay. Can anyone just yell it out? What are we thinking here? Is it positive or negative based on what I just went over? Nobody wants to help me out? It's pointing down as I'm going to the right. Negative, thank you. Okay, so you would just say negative. You will have a test question that's like this too. So if you're like, wow, this is so easy, awesome. Like, make sure you understand it then, because you're going to be seeing other problems like this. Okay, the second thing I'm going to be asking is, what is the lowest possible degree for this? And what you do is you just count up how many extrema there are, how many turning points there are. There's 2 turning points. And you add 1 to it, and you would say the lowest degree is 3. Okay. You take however many turning points there are. I'm just going to say turns. I don't know why I say turning points. Turns plus 1. There's 2 turns. So you add 1 to it, and you get 3. Okay. This is equal to the lowest degree. Oops. Okay. Next thing I'm going to ask is, I didn't really draw this graph very well, so that's kind of embarrassing, but let's just say 1, 2, 3 kind of gives it away. But it would ask for, what are the x-intercepts? and you would just say it's at x equals 3. Okay. I should have drew the numbers ahead of time. So it's my bad. 1, 2, 3, 4. Okay, so for the y-intercept, it intercepts at 4. So you'd say, whoops, that's embarrassing. You'd say y equals 4. Okay, any questions on that? Okay. Another way you could have done these problems, I'm going to just make a graph real quick, is where you have to kind of figure out what the equation of it is. So let's do this. Let's do something like this. Okay. Now, I'm looking for this one, it says, which of the following is true? All right. I shouldn't say true. I should just say, which is the correct equation? All right. Correct equation. Okay. So A, I'm going to say y is equal to 3x squared plus 1. B, I'm going to say y is equal to 2x to the 4th minus x to the 3rd plus 1. C, I'm going to say y is equal to negative 2x to the 4th minus x cubed plus 1. And then D, I'm going to say y is equal to 4x cubed minus x squared plus 3. Okay. So it would say, which of the following could be the correct equation for that graph? Okay. This is how I would do it. I don't care how you do it, but this is like what makes sense to me. First thing I look at is where it's pointing. Okay. From left to right, this is pointing up. So because it's pointing up, that leading coefficient should be positive. Okay, so that means C is automatically out of contention because of that negative there. So it cannot be C. Okay, so now I only have 3 choices. From here, I'm going to count how many turns there are. There's 1, 2, 3 turns. So if I take those 3 turns and I add 1 to it, that means the lowest possible I can have is an x to the 4th. Okay, so anything that's not x to the 4th, I'm going to get rid of. This one's x squared, I'm getting rid of it. This one's x to the 3rd, I'm getting rid of it. The only possible answer left is B. Okay. Then I would look at the x and y intercepts. Well, the y intercept, if you plug in x is 0, this is all gone, and it's 1. You can see that it's possibly 1 right there. I didn't label it. But you don't even need all that because it was the only one that was left, so it had to be the right answer.